This is video 3 on the terms of orientation. Please remember to take notes using the Cornell Notes system we discussed in class. At the start of the next class, there will be an open note quiz on this material. Remember, you are allowed to use only notes you have taken yourself. Anatomical terms of direction are important for doctors or medical professionals because it gives them a universal language to describe the human body. It is based on a universal position called the anatomical position. This is with the body standing upright, feet shoulder apart, legs are parallel, and toes are pointed forward. The upper limbs are held out to each side with the palms facing forward. We are about to discuss the terms of direction, and you'll note that they're easiest to be studied in pairs. Superior means towards the head, and the opposite is inferior, away from the head. Anterior or ventral means towards the front of the body, and the opposite is posterior or dorsal, towards the back of the body. Medial means towards the middle, and the opposite is lateral, away from the middle. Proximal means towards the body trunk, and the opposite is distal or away from the body trunk. These are terms mostly reserved for limbs. Superficial means towards the body surface, and the opposite is deep or away from the body surface. There are 3 ways to section the body. Each direction of section is called a body plane. Median or mid-sagittal cuts the body in half, separating the arms left from right. The frontal or corneal plane sections the body so that the arms are cut anterior from posterior. The transverse plane is parallel with the ground, sectioning the body from inferior from superior. There are 3 major body cavities. A cavity is a compartment within the body. The cranial is just how it sounds. This is inside the head and contains the brain. It's protected by the cranial bones and is filled with cerebrospinal fluid. Next is the thoracic cavity. This is the chest region and is protected by the rib cage. It contains the lungs and heart. It is separated from the abdominal cavity by the diaphragm. Last is the abdominopelvic cavity, or your stomach. This is the cavity inferior or below the diaphragm. This cavity contains the digestive and reproductive organs. This is an illustration showing the mid-sagittal section of the body on the left with the cranial, thoracic, and abdominal cavities labeled. On the right is a frontal section of the body with the same 3 cavities labeled again. There are several medical terms to define the specific body regions. You will need to know the body regions labeled on the diagram below, but we will practice these in class. Medical imaging has come a long way in recent years. One tried and true method for imaging a living body is X-rays. X-rays are high energy radiation. The individual stands in front of a specially treated metallic plate. The X-rays are directed at the individual. The denser the tissue, the more resistant it is to X-rays. This works like a shadow on the X-ray films. The soft tissue only slightly block the X-rays so they appear gray on the film. The denser tissues, like bones, block the X-rays from reaching the film so they appear white on the film. This imaging is mostly used to visualize hard body tissues like teeth and bones. X-rays are capable of doing damage to DNA and possibly initiating the changes that can lead to cancer. Most people know the story of Marie Curie, who discovered the power of X-rays. Exposure should be limited. Your clinician will help you weigh the benefits versus the risks of any medical procedure, including X-rays. A special use for X-rays is the CT. Here, an individual lies on a motorized platform while a computerized axial tomography, or CAT, or CAT, scanner rotates around the individual 360 degrees, taking hundreds of X-rays. A computer is used to render a very detailed image of the structure being examined. This is still a technique that is best for denser body tissues, but also exposes the individual to a very high dose of X-rays. The MRI, or magnetic resonance imaging, also uses a CAT scanner, but instead of using high-energy radiation X-rays, it uses magnetic fields and radio waves. This can be used to detect and image various cancerous tissues because they give off a different signal using this imaging than a normal body tissue would. This imaging is very expensive. can also be very disorienting to the patient because it is loud and in a confined space. Since this uses very strong magnets, any individual with metal devices cannot have an MRI. PET, or positron emission tomography, PET, is the first imaging that we've discussed that allows real-time images of the physiology. This uses radioactive pharmaceuticals injected into the individual that emit radiation that's detected by a sensor. A computer is used to render a real-time image showing the physiological activity. Last but not least is the ultrasound. This is the lowest risk imaging, but one of the lowest resolution imaging methods available. Ultrasound works by transmitting high-frequency radio waves into the body and recording an echo. This imaging method also gives details on the real-time physiology. Because of the low risk to the individual, it's the preferred imaging method for fetal growth and development. The negatives of using this method is the low resolution of the image, and the quality is heavily operator dependent. Please review your notes for the answers to these questions. You should record the questions in the left-hand column of your Cornell notes near the notes that answer these questions. Please review your notes. Try to record any additional questions you could answer from this material in the left-hand column. Don't forget to write down your summary of the notes at the bottom of the page along with any questions you have. Until next time, think, wonder, and question.